The sine rule can be used to work out missing sides or angles in triangles. Now let's take this triangle labeled ABC. The length of the sides of this triangle are A, B and C. The length of the side AB is C and BC is A and AC is B. Now as you can see here, this triangle can be split into two right angle triangles. So let's label this point X. The length of CX is H. So in my previous Pure Maths video, I covered about the standard trigonometric ratios for right angle triangles. If you want, check it out for more details. Just like the cosine rule, you can use the standard trigonometric ratios for right angle triangles to prove the sine rule. Now in the triangle CBX, let's use the sine ratio to find the angle B. So sine B equals H over A as sine theta equals opposite over hypotenuse. Rearranging this gives us H equals A sine B. Now, in the triangle CAX, use the sine ratio to find the angle A. In the right angle triangle CAX, the hypotenuse is B, so sine A equals H over B. Rearranging this gives us H equals B sine A. H equals A sine B and H equals B sine A. Equating the two equations gives us A sine B equals B sine A. Now, to solve this equation, let's divide throughout by sine A sine B. Then A sine B over sine A sine B equals B sine A over sine A sine B. So A over sine A equals B over sine B. In a similar way, by drawing the perpendicular line from B to the side AC, we can show that A over sine A equals C over sine C. So still the triangle ABC can be split into two right angle triangles. Now let's label this point X. Let's say the length of BX is now H. In the triangle CBX, the hypotenuse is A. Here we can use the sine ratio to find the angle C. So sine C equals H over A. Rearranging this gives us H equals A sine C. Now if we take the triangle BAX, here the hypotenuse is C. Using the sine ratio in this triangle to find the angle A gives us sine A equals H over C. Rearranging this equation gives us H equals C sine A. So H equals A sine C and H equals C sine A. Equating both these equations gives us A sine C equals C sine A. Divide throughout by sine A sine C, then A sine C over sine A sine C equals C sine A over sine A sine C. A over sine A equals C over sine C. So A over sine A equals B over sine B and A over sine A equals C over sine C. Then A over sine A equals B over sine B equals C over sine C. So this is the sine rule. Now this version of the sine rule can be used to find the length of a missing side in a triangle. For example, calculate the value of X. Here we know the size of two angles and the length of one side opposite to a known angle. Now we can use this version of the sine rule to find the length of the missing side. A over sine A equals B over sine B. Then 6 over sine 53.2 degrees equals X over sine 36.8 degrees. So X equals sine 36.8 degrees times 6 over sine 53.2 degrees. X equals 4.49 centimeters. Here I gave the answer to three significant figures. Now in this triangle ABC, we know the size of the angle A and B and the length of the opposite side to the angle A as 8 centimeters. To find the value of B, we can use the formula A over sine A equals B over sine B. So 8 over sine 30 degrees equals B over sine 72 degrees. B equals sine 72 degrees times 8 over sine 30 degrees. B equals 15.2 centimeters. So as we saw earlier, this version of the sine rule can be used to find the length of a missing side. Now this version of the sine rule is used to find a missing angle. For example, find the value of X. Now here we know the lengths of two sides and the size of an angle. So here we know the length of the side opposite to the angle 75 degrees as 5.5 centimeters and the length of the side opposite the angle X as 3.9 centimeters. So we can use the formula sin C over C equals sin A over A to find the value of X. Then sin 75 degrees over 5.5 equals sin X over 3.9. Sin x equals 3.9 times sin 75 degrees over 5.5. To solve this equation, take the inverse of sin. Then x equals sin inverse 3.9 times sin 75 degrees over 5.5. X equals 43.2 degrees. Now here we can also use the formula sin C over C equals sin A over A to find the value of x. So sin 67.5 degrees over 7.2 equals sin x over 5.8. Sin x equals 5.8 times sin 67.5 degrees over 7.2. Then x equals sin inverse 5.8 times sin 67.5 degrees over 7.2. X equals 48.1 degrees. Let's take a look at another example. In triangle ABC, AB equals 15 centimeters, BC equals 12 centimeters, and the angle ACB is 75 degrees. Find the two remaining angles. So first, let's draw a diagram and add all the data. Now here, we know the lengths of the two sides AB and BC and the size of the angle opposite the side AB as 75 degrees. So first, let's find the angle A. Here, we can use the formula sin A over A equals sin C over C to find the angle A. Then sin A over 12 equals sin 75 degrees over 15. Sin A equals 12 times sin 75 degrees over 15. Taking the inverse of sin gives us A equals sin inverse 12 times sin 75 degrees over 15. A equals 50.6 degrees. So, the size of the angle BAC is 50.6 degrees. As we all know, the total of the size of the angles in a triangle add up to 180 degrees. So, the size of the angle ABC equals 180 degrees minus 75 degrees plus 50.6006 degrees. Here, I didn't write the size of the angle BAC to three significant figures to get a more accurate answer. So, ABC equals 54.3994 degrees. Then, the size of the angle ABC is 54.4 degrees.